our next little section here, we're exploring the differences or the performance benefits that come along with using the XslCompiledTransform class, rather than the, I guess, older way of doing it, the XslTransform. Right. So basically, this is offered as a new feature for BizTalk Server 2016, and I guess that's actually a little bit misleading. In BizTalk Server 2013, maybe it was 2013 R2, they just did a unilateral switch from the XslTransform to the XslCompiledTransform, and that worked for some people, and it didn't work for other people, and therefore now they've offered it as an opt-in, opt-out sort of thing. You can make this decision for yourself, right? So a little bit of context, a little bit of background regarding these two different classes that we're talking about. The XslTransform class was part of .NET Framework 1.0. It's now been deprecated. It's actually been deprecated for a number of years. But it is what the BizTalk mapping engine was built upon. And with the release of .NET Framework 2.0, we had the introduction of the XslCompiledTransform class. And this was intended as a replacement for the XslTransform. Okay. Now in 2016, BizTalk 2016, we have the opportunity to tell our BizTalk maps which one of these two classes we want to target as the underlying transformation for our maps. Right. Now, the key difference between these two classes is that XslTransform, the traditional old, I guess you'd say, old way of doing it, is that it's an an XslT interpreter, whereas the compiled transform is an XslT compiler. Right. Now, in simple terms, what that basically ends up meaning is that the XslTransform class is reading that XslT or that style sheet or whatever the case may be, and it's executing it like it's the first time that it's ever seen it, every single time that it runs. Right? Whereas the compiled transform is looking at that XslT or that style sheet, and it's compiling it and then running from that compiled code. Right? Now, what that ultimately means is that the XslCompiledTransform ends up running faster once that compilation has been done. Once the initial load is completed, then our subsequent transforms end up being much quicker. Right? And here we've got a little screenshot. This is coming out of an MSDN article that was published years and years ago when the XslCompiledTransform was still a new thing. But it's showing a very simple .NET application that was just running these transformations. We see our load time for the XslTransform is about 90 milliseconds, whereas the compiled transform is like 880 milliseconds. Right? But we see from there, our transformation times, right, end up being quite different. Right? The transformation for the compiled transform ends up being a lot faster than the transform for the XslTransform. And on subsequent executions, that's just the first transform. On subsequent executions, I mean, the difference between 75 milliseconds and 2 milliseconds is pretty big. Right? That's where our real performance gains lie. Okay? So, this is all just straight up .NET. Right? What does this mean for our BizTalk maps? Okay? Well, like we said, you have the opportunity to choose which of these transform classes you want to use. The way that you do that is you go into your BizTalk map, you hit the map grid, and then over in the properties there's a new property for BizTalk Server 2016 that is the Use XslTransform property. Right? By default, that is set to true, which means by default you are using the old XslTransform class. If I change that to false, I'm going to use the XslCompiledTransform instead. Right? So making that change, I mean, that's a trivial change. That's no effort at all. Okay? I was thinking, talking to you guys today, like doing a demo showing you this, that's not going to be very exciting at all. Right. What I thought was maybe a little bit more exciting was trying to assess or measure what kind of difference there actually is in the XslTransform versus the compiled transform. Right, and to do this, I designed a simple test. I ran the test, so you're not going to sit here watching me submit a bunch of messages and then, measure performance counters and garbage like that. That's, again, kind of boring demos. At least today, here and now, we don't have time to go into a lot of detail there. So I designed a simple test. I ran a series of tests. And my test basically lays out like this. All right, I created a map that has about 60 functoids in it. I wanted it to be a non-trivial map. So we're doing quite a bit of work inside that map. And then I created a copy of that map, and I configured one to use the XslCompiledTransform, where the other uses the just regular XslTransform. Right. From there, I built and deployed my project, and then lastly, created a BizTalk application where I'm basically just receiving the message, routing that message to a send port, and it's within that send port that I was executing the map. No orchestration or anything like that. And then for my submission, I built out a batch file that simply grabs a bunch of files and drops them in the in folder for BizTalk to eat. No real big deal. Very simple thing, probably the sort of thing that we've all done at one point in our BizTalk lives. Right? So I ran this test, and well, this is what my results look like. I ended up averaging everything out, making it really easy. Oh, I failed to mention one of the tests that I was running the whole time was what happens when I don't have a map at all. And I'm looking at these results, and it just doesn't make sense. Like, how in the world is not running a map? How is that worse, and not just a little bit worse, but like twice as bad as doing the compiled transform? Like, that doesn't make any sense. How is doing less work costing me 2 times as much? Okay. So I'm looking at all this, and it doesn't make sense. The compiled transform is taking longer on average than the XslTransform. Right? And I understood that the real performance gains with that compiled transform was when everything gets loaded, right? It gets faster. It's faster once everything is loaded. So I thought, oh, well, I'll take this, and I'll do the most reasonable thing. I'll throw more at BizTalk, right? Once it's loaded, maybe I didn't load it hard enough, right? It's not cached quite enough, right? And I increased my message load by a factor of 10. So instead of submitting 100 messages, I throw 1,000 messages at BizTalk. And really, not surprisingly, that didn't fix the problems at all. Right? I mean, this really just made everything worse. On average, those send port instances were taking about 3 times longer to run. Right? And that is an important thing. We're measuring the duration of the send port, right? Not just simply the map. Right? Anyway, things are taking 3 times longer to run here. Still, obviously, something isn't right, because all of the things that I know about what the difference between compiled and non-compiled are supposed to be, right, they're just not being borne out. So I did the next most reasonable thing. Right? I didn't increase by another factor of 10. That would be just insane. I went and I asked Nick. And I said, hey, Nick, tell me why this doesn't work, because I'm stumped. And Nick said, did you look at throttling? And my response was, well, not of course I looked at throttling, but like, oh, of course I should have looked at throttling. As a matter of fact, in my performance counters, I could clearly see that rate-based throttling was being enacted, was triggering for both the receive port as well as the send ports. Right? So I went through, disabled all of that rate-based throttling, just said, no BizTalk, you just do what you do and throttle not at all. And I ran my test again. 1,000 messages, throw them in the in folder with no throttling at all. And things started looking a little bit better, right? Somehow the the no map option is still the worst. But at least, like, our one small win here is that that compiled transform is running the fastest. It's a small win, but still not what I expected. What I really expected to see here is, like, no map is that big, right? And all of this is gone. Like, that's the kind of bar graph I was expecting to see. Right, so something's still a little bit goofy here. Right? Obviously, throttling's not the culprit. I could prove that in my performance counter samples. I started thinking, well, what else could be kind of messing with our results here? Right? And I kind of theorized that it was the way that I was submitting the messages. If you think about it, that burst of 1,000 messages all at once, right, that's subject to a lot of other things in BizTalk, right? That's not just go execute this map 1,000 times. That's not what's happening. We've got adapters, we've got the message box, we're publishing messages, we're picking them back up, we've got internal message queues, we've got host instance thread pools. There's so many other factors that come into play, right? But that 1,000 message burst of data was being influenced by. So I wanted to change the way that I went about submitting those messages. Right? And probably one of the easiest ways to really control that rate of submission is using a tool called BizTalk LoadGen. Grab BizTalk LoadGen off the internet, install it, and I set up a very simple test where I could control that rate of submission. And instead of throwing 1,000 messages all of BizTalk throwing 1,000 messages at BizTalk all at once, I instead set up LoadGen to say, let's submit 1,000 messages, but let's do that at a rate of 10 messages per second. And once I'm submitting at that rate, and I'm not running into all of those other influencing factors, I'm finally seeing the sort of results that I expected all along. No map, 16 milliseconds. Compiled transform, 21 milliseconds. XslTransform, 29 milliseconds, on average across the 1,000 instances. All right, and I was not satisfied with that. What I saw in looking through all of my performance counters and my service instance duration records, is I saw a bunch of fluctuations in that processing time. I mean, some of those compiled transforms, they were taking 100 milliseconds, 200 milliseconds. Some of them were taking 2 milliseconds, 3 milliseconds. Right? That's our average is 20, but there are definitely a lot of samples bigger than that or higher than that, and a lot lower than that as well. Right? Here we see kind of our adjustment, right? Non-adjusted, the map, or no map is 16, right? And really on top of that 16, what we're showing here is the XslTransform is adding 13 milliseconds to our execution time. The compiled transform is adding 5 milliseconds. And so just kind of trying to show the difference there. Anyway, like I said, I wanted to reduce that fluctuation in service instance execution times. Right? So I used the same load size, but I reduced my rate of submission to 1 message per second. Now at 1 message per second, we see that our average execution times did go down significantly. Right? And I think that's kind of an obvious expectation to have. But what's more interesting than that is looking over here at the bar graph, the proportions between those 3 bars are roughly the same as what they were in the last round of tests. We go back and just quickly flash to it, and there's 10 messages a second, there's 1 message a second. Right? But the proportions of those bars are roughly the same. And again, we've got our kind of adjusted numbers, seeing that the XslTransform is adding really just 2 milliseconds, but the compile transform is still faster at 1 millisecond on average added versus not running a map at all. It's kind of wrapping all of this up, my conclusions. Right? What did I learn? What can I definitively say based on my experiences here? Right? Well, number one is the numbers prove it, right, that XslCompiledTransform is going to execute faster than the XslTransform, right? Especially after that initial load. That is something that I will say that first execution is slower for the compiled transform, but it's subsequent executions where we start to see those performance gains, right? And it's really easy to do. So I don't really have a great justification for why I wouldn't do it. The one technical reason that I know not to do it is if you have a functoid that returns a null result, using the compiled transform changes the way that behavior works, which might end up breaking other parts of your map. And so, assuming I'm not going to have any sort of heartburn there, I don't have a great reason why I would choose not to use the compiled transform. But probably the most, impactful thing that I took away from that whole experience, right, and this is something I've known for a long time, is that really BizTalk server is this really complex, really sophisticated system with tons of moving parts. Right? And not trying to disparage anything about what Microsoft has said regarding this, but we were told, hey, yeah, use compiled transform, your performance is going to be better, yada, yada, yada. Right? And what this, I think, really ends up proving is while the compiled transform is technically a performance gain, the likelihood that you have other bottlenecks and other issues that kind of negate any sort of performance gains that you might get from flipping that one property from false to true or true to false. Misremember now. But the likelihood that you have bottlenecks that are really just preventing you from fully realizing these performance gains, I think it's pretty high. And it kind of made me wonder, how many people out there are never going to actually do these tests? They're never going to evaluate for themselves whether or not they're getting that performance gain, whether or not this is a good thing for them. Or they're going to go through the effort of identifying those bottlenecks and eliminating those bottlenecks. How many people just don't even know where to start when it comes to figuring that stuff out? And if you're one of those people, I'm making no judgments. I know lots of people are in that boat. Right? We've got courses that we offer that will teach you exactly what you need to know in order to make those, assessments for yourself and implement those optimizations and really see these performance gains for yourself. Anyway, that's my bit. Do we have any questions? Nick?
Yeah, so one of the questions, I'd answered it in chat as well, but question that maybe other people might have too, why wouldn't we use the XslCompiledTransform? Really, when would I decide to turn that off?
Uh-huh.
And why would they make that a feature to be able to turn it on now?
Okay, so you answer that in chat. Do I have to read your chat, or are you just going to answer it for us?
Oh, no, you can answer it.
Right. Well, I mean, I said it when we were talking. The functoids returning null results, right? The behavior is different, and if you have other functoids that's chaining into that are expecting the XslTransform behavior for null result, then that could end up breaking those subsequent functoids and really just require redesign of map, I guess. That's really the one big justification, and I think that's probably not a very common use case.
I got another question for you.
Okay.
Will that also be beneficial if the map is used in an orchestration?
Yeah, so that's a good question. Absolutely, right? I mean, you know, initially when we were designing all of this, right, I had consulted with Nick on this, and I was like, Nick, should I use a transform shape and just measure how long the transform shape is taking, or should I do the, you know, do the send port thing instead? And we ultimately opted for the send port instead of the orchestration for a variety of reasons. But there's nothing to say that doing that transformation inside the orchestration would not benefit in the same way that that we saw in the send port. Okay? No, I guess, no, somebody's asking, deep dive course cover performance optimization. So yes, but I don't want to turn it into too big of a sales pitch, Daniel, but the place that we cover that performance optimization and, you know, things like throttling and all of that, measuring performance, evaluating performance, all of that, that is our BizTalk administrator deep dive. Our developer deep dive, we're focusing a lot more on building those applications and services, whereas the administrator deep dive, we're looking at, you know, optimizing those services and making them as healthy and giving them the best performance possible.